Here we have the infinite series of negative 1 to the n dividing by 4 to the n. And we want to show that this alternating series converges absolutely. And here's the definition of absolute convergence. And so a series that converges absolutely, if we put absolute value around the a sub n and it still converges, then we say that it converges absolutely. And so we have to show we need to show that if we put absolute value around that and this still converges, now the only difference between this and this is the negative 1, but once we put the absolute value around the negative 1, and this becomes 1. And this becomes just 1 dividing by 4 to the n. Because the absolute value made the negative 1 becomes positive. And then this series right here, we can rewrite it as 1 over 4 to the n. And this is a geometric series. Geometric series with common ratio r equal to 1/4. And since we have r is between negative 1 and 1, this series right here converges by geometric series test. Recall that the geometric series test says that if the common ratio, if it's between negative 1 and 1, then the series converges. And since this right here is equal to this, and so we have shown that the series with the absolute value converges and therefore the original series, this series right here, converges absolutely. And so to recap what we just did, so given this series right here, and we want to show that it converges absolutely, then what we need to do is put absolute value around the a sub, around this expression right here, and then show that even after we put in the absolute value and it still converges, then we say that the series converges absolutely.